Hey everyone, I'm going to do some exponential function notes here real fast, and I just want to show you a pattern and get your thoughts on it. So here's the pattern. It's 1, 2, 4, 8, and 16, and so forth. The rule is that you're doubling it every time, or in other words, multiplying by 2. And I'm just going to fill it out here. What I want you to notice is that because it's multiplying by 2 each time, for example, to get 8, which is kind of like the third step if you start in step 0 for 1, then you're multiplying 2 by 2 by 2, 3 times to get 8. So the way we write that in formula is 2 to the x. So f of x equals 2 to the x. When x is 4, it's 2 times 2 times 2 times 2, or 2 to the 4th power, which is 16. And that fits all the things in the output there. Now, to graph this, we need to also find -1, -2, and -3. And if you remember from back earlier in the year, we learned that 2 to the negative first is 1/2, or 0.5. And when you have a negative power, it just means a power in the denominator. So 2 to the negative second is 1 over 2 squared, and so on and so forth. So when we plot those 3 points, or all the points, we get the points get twice as high each step right on the right side, and on the left they get half as far or half as close to 0. And it gets to 0. It gets close to 0 really, really fast. We actually have a name for that. See that dashed line where our green curve gets closer and closer to the x-axis but never touches it? That's called the asymptote. But that is the graph. And what I want you to notice is how quickly it gets big as you go to the right and how quickly it gets small as you go to the left. That is one of the hallmarks of an exponential function. What I'd like for you to do right now is type in this function, f of x equals b to the x into Desmos, and make a slider for b and see what happens when you change b around. I'm particularly interested in when b is less than 1 but positive, and then when b is greater than 1. And you are going to make these graphs before coming to class and compare what you got on Desmos to what your classmates got. Also answer those questions. So, this example question, you need to go ahead and pause the video to answer those on the other side, and once you finish that, you can come over here. I'm going to be using Desmos, but I'll make a separate video for if you want to see how to do this on your graphing calculator. First of all, we'll type that in Desmos. So I get f of x equals 20,000 times 1.05 to the x. And the only thing that is raised to the power is 1.05 when it's typed in like this. Notice if you click the wrench, you can make your domain and range like I did. The x's you can put in about those, and the y's put in about those. And if you want to make a table out of it, you go ahead and press this cog right here. And when you get the cog, you should get a screen that looks like this. You can press that button right there to make a table. And then once you have the table, it's just a matter of typing in 3 and 4 and 5. And actually, once you type in 3, if you hit enter, it should make the whole list of values for you. And also you notice there are points there. So there's the table for you, and there's the graph. And you can graph those. Instead of graphing those, I'm actually going to import just this picture and use that to talk about some of the stuff. So, is the function increasing or decreasing? This is actually increasing because as you go to the right, it's going up. It is also, as the years go by, the population goes up. And we know this will be true because b is greater than 1, because b is 1.05. That 1.05 is important because that is the growth factor. That's how much it's increasing by each year. Now, when is the population, or what is the population in 2010? Well, the x value is how far after 2000 is. So when we get 10, we want to find out where is that value on the graph, and that y value, that is the population at 2010. Fortunately, instead of having to guess from our graph, we can also find this from the table right there. So the population is 32,578, and I'll be generous and round up. because you can't really have half a person when you're talking about population. To find what the when will the population reach 30,000, we want to see 30,000 on the y-axis and see what x value that becomes. And what you can do is you can actually type in y equals 30,000 into Desmos and find out what is the x value of that point. And I will leave that up to you to do coming into class, as well as trying to answer that last question. Thanks for watching.